Alright, 3.5 Features of exponential functions. The objective: students will be able to identify key features of exponential functions. Alright, so remember we've already learned about an exponential function that it comes in the form f of x or y equals a, your initial value, times r, your common ratio, with r being raised to the power of x. So we're going to just kind of figure out how to find these values. We've already kind of done this a little bit in the last video, but we're still going to just play with it a little bit. So this first one, part 1, identify the initial value, the common ratio, and the specific value of the function. So I want to point out that this is part 1 of part 2. You have to do this part first often, and then you can answer this question down here. But we have to do this part first. So let's go ahead and do that. It says we're going to identify a, r, and f of 2. Well, this is easy. We could just see by looking at it that this is our a value. It's 8. And our common ratio is 1/2. So now to find out what f of 2 is, that's just what I get when I plug in a 2 for x. So that would be 8. 1/2 to the second power is 1/4. And 1/4 of 8 is 2. So f of 2 is 2. Alright. So go ahead and do that for practice number 2. You're just identifying all the parts that they're asking for. And then I would unpause the video when you're ready to check your work. Okay. I got that my a value is 9, my r value is 1/3, and then if I plug in -2, I would get 9 to the 1/3 to the -2. Now this is important. Remember that a negative exponent basically just flips. It's like the reciprocal of whatever it is we're raising to that exponent. So we could write this as 9 times 3/1 to the +2 power. And 3/1 is just 3, so you get 9 times 3 squared, which is 9, which is 81. So there you go. We found all the parts. Now we can work with part 2. And this is the part that's maybe a little bit more challenging, but we've got to be able to do the first stuff. So it says use the functions above. For which values of x does the function equal the following value? So we're actually going to solve for x. So if f of x was 32, and we know that f of x equals 8 times 1/2 to the power of x, we're going to solve for x. So the first thing I'm going to do is I'm going to try and get this thing that's being raised to the power of x all by itself. That's step 1. So to do that, I got to get rid of this 8. Well, it's 8 times this, so I'm going to divide by 8. I'm going to zoom in so it's a little bit easier to work with. So 32 divided by 8, that's just 4. So you get 4 equals 1/2 x. Okay, so this is very similar to those logarithm problems. I want to try and get these bases to match, right? And I can do that because I see this has a 2 in it, and 4 I know I could write was 2 to the power of 2. So I'm going to go ahead and do that. I'm going to write 4 as 2 to the 2 equals, and I know that if I made this exponent negative, that's like flipping this. So I'm actually allowed to write this as 2/1 to the power of -x. Hopefully you catch on what I'm doing there. Well, that's the same thing as 2/1 is the same thing as 2. So I could just write 2/2 equals 2 to the -x. Well, now that my bases are the same, so they both have a base of 2, now I can just make the exponents equal. So that means that I know that, I'll just do it in red, 2 equals -x, therefore x equals -2. And so I have solved for x. That was kind of the same thing we did when we were messing with logarithms. And technically we could write this as a logarithm as well. We could have said from this step, I'll do it in blue, I could have said, hey, you know what, that's the same thing as log 1/2 as my base of 4 equals x. And if I was to evaluate log of 1/2 of 4, that would be -2 as well. But I think it's better for us to kind of just play with this, get in the habit of being able to rewrite things with the same base, because that really trains us in what we need to do to solve these types of problems. Okay, so you have a similar problem here. It's saying if f of x equals 1, so if this whole thing equals 1, what does x equal? So I would recommend that you go ahead and pause the video, try this problem out, and then unpause it when you're ready to check your work. Alright, so I just went ahead and took the function that I knew it was, 9 times 1/3 to the power of x, and set it equal to my 1. I wanted to get this 1/3 to the x all by itself, so I divided both sides by 9, so I got 1/9 equals 1/3 x. This one was a little bit easier because I could tell just by looking at 1/9 that I could kind of take the square root of that, and that'd be 1/3. So I can write 1/9 as 1/3 squared. Those two things are equal. And then this would stay the same, so once my bases are the same, my bases are both 1/3, I could write this as 2 equals x, or x equals 2. And this little symbol here just means therefore. So I said therefore x equals 2. That's all there is to that. Okay, now it says use the values of the function given to identify the initial value on the common ratio. So now they're giving us a table. This is very similar to that graph that they gave us in the last video. And they want us to find the a and the r value. And last time I did that by using systems of equation, which we can do here as well. But I wanted to show you something else on a way to find the ratio. A ratio is going to be a ratio of any of these terms. So I can actually say like, hey, well, I know that there's some ratio between 128 and 32 because it went from 1 to 3, and so there's going to be some ratio here. So here's what I can actually do. I know that, I'm going to zoom in a little bit. I know that f of 3 equals 32. Right? If I plug in a 3 to the function, it equals 32. Well, I also know that f of 1 equals 128. And I can do this with any two sets of numbers. So that means that f of 3 divided by 1 equals 32 divided by 128. It's pretty simple because they're the same thing. Well, since 32 equals f of 3, here is my f function that I could just plug a 3 into. So I could actually say that 32 over 128 equals, and the 32 part would be arx, but the x would be 3. So I could say ar to the third. And the 128 part, well, that equals ar to the 1. So I could just write ar to the 1. And it doesn't matter which ones you use. It's generally better to have the r with the bigger exponent on top, but it doesn't matter. You'll still get the correct answers here. This is how you could find the ratio. Because what happens here is your a values just cancel out. And so you're left with two fractions that can be reduced pretty easily. 32 and 128. Let's see, I don't know how to reduce that right off the top of my head, but I know that I could take a 4 out of both of those. I probably could take something more. I'm going to get the calculator out and just check. 128 divided by 32. Yeah, so I could take a 32 out of both of these actually. So take one 32 out of there, and I could take 4 32s out of there. And then the other thing that I want you to see is, see how I have an r cubed over an r to the 1? Well, we learned that we could just subtract exponents. So this is like, this r would cancel out, and this would become r squared. So let's write this all out. This looks like 1/4 equals r squared. Alright, well now we're really close to finding our r, right? Without much work. So, all I got to do is take the square root of both sides. And I get that my r value is the square root of 1/4, the square root of 1 is 1, the square root of 4 is 2. So I have found my r value, and it wasn't that hard. Now I can go to find my a value. I can plug this in to this function with either the 1, the 3, or the 6 in there. It doesn't really matter, just as long as I plug it in with an f of x value and an x value. And I'll do that in a second. But the other thing to remember here is that if r is 1/2, that means for every x value, this is going down. It's being cut in half. So I actually know some values here. I actually, like, if I wanted to plug in a 2 to this function, I know what it would be. It'd be half of 128, and that's 64. Right? So this is just kind of a little side note. If I wanted to, I could say, hey, like that's 2, and this is 64. And notice then when I go to 3, 32 is half of 64. And then I could find value of 4. 4 is half of 32. It's 16, and then half of 16 is 8, and then half of 8 is 4. That's how this thing is working. So I could actually find the a value, or initial value, by just going backwards. It would be whatever 128 is half of. So if I double 128, I have my a value. So I know that's a little confusing. I'm just looking at the pattern, trying to figure it out, but I'm going to show you the math for it as well. But my point is you don't always have to plug things into a formula. So I'm going to just go ahead and say that I know what my A value is. It's 128 times 2, which is 256. But I'm going to prove that to you using some algebra. Okay? So let's go back to this original function and let's plug in what we know and we'll solve for A and see if we get the same thing. So for example, let's use the 1 and 128 point. So when f of x is 128, we could say that equals A. My r value we found to be 1/2, and when f of x is 128, the x value is 1. So I could just say 1. Well, let's just do some math here. I get 128 equals, well, 1/2 to the 1 is just 1/2, so I really just have A times 1/2. And now I could do a couple things. I could divide both sides by 1/2, but dividing by a fraction is kind of silly. Instead, what I'd rather do is just multiply both sides by 2. If I multiply this by 2 and I multiply this by 2, 2 times 1/2 is just 1, so these guys cancel each other out to be just 1. And on the right I have an A, and 2 times 128 is 256. And sure enough, look, I solved using algebra for the same thing that I got just using some kind of reasoning of understanding what an exponential function does, what the common ratio means. So we got 256. So we got all the parts. We can now write the function. We could say, hey, f of x equals 256 times 1/2 to the power of x. There's the actual whole function there. Okay, I want you guys to try that one. Try all these steps again. I'm gonna set you guys up for this one just to show you what I would do. I wouldn't recommend using this coordinate point because it's got this decimal in it, and I just feel like it could still work. It's nothing wrong with it. It could still work mathematically. It's just probably going to be more work than you need. I would use these 2 points here. And remember, we take the bigger r value, we put it on top. So I would say, this is how I would start. I would say that g of 2 equals 9, and divide that by g of 1, which equals 6. And then actually write out the functions as well. So that means 9 would equal a r to the 2, and 6 would equal a r to the 1. Notice the x value goes here, the x value goes here. Make that into a ratio, and now you have a pretty simple equation to solve here. Remember, the a's will cancel out, then you just solve for the r's, okay? So I'm going to let you guys work on that one. Then once you solve for the r, try and solve for the a, and then write your function. So give you a second to work on that, and then you might want to unpause the video when you're ready to check your work. Okay, so I just went ahead and reduced this function. 9, 6 reduces 10 to 3/2. The a's cancel out, and r squared divided by r1 is just r. So I didn't have to do much, and I got my r value. It's 3/2, or we could say 1.5. So before I did any more math, I just looked at this and I said, hey, if 1 gives me 6, and I know my a value is when x is 0, I could really just say, well, 6 is 1.5 times of what? Well, the answer is 4. 4 times 1.5 gives you 6. So I think that my a value is going to be 4. Let's just prove it algebraically. I know that my g of 1 equals 6, so I could say 6 equals a times 3/2 to the power of 1. 3/2 to the power of 1 is just 3/2. So I'm going to multiply by the reciprocal to cancel that out. So I multiply both sides by 2/3. When I multiply by 2/3, I have a 6 on top, a 3 on the bottom, so I could reduce that to a 2 and a 1. So I just have 2 times 2 divided by 1. Well, 2 times 2 is 4, and 4 divided by 1, of course, is 4. Hey, so look, I get a equals 4, which is the same thing I said it was going to be. So I wrote my function, g of x equals 4 times 3/2 to the power of x. Okay. Alright. Got a little bit more to do here, and then we will be done with these notes. So find the value of the function for the indicated value. So now they give us the function and they give us a graph, and they want us to find it for a certain x value. So they're telling us -1. Well, in order to do this, I can't just look at the graph because -1 doesn't, my graph doesn't show up for -1. But I can use the graph to create a function like we did before and then evaluate it at that point. Alright? So let's do that. And I actually can see my initial value right here. It's when x is 0, I know my initial value, it's negative 6. So I already know that g of x equals negative 6. And then I could put an r there. Well, what is my r value? Well, I can actually figure that out as well. Look, I went from negative 6 to negative 2. So what is the ratio? What's the ratio that's happening here? Well, negative 2 is a third of negative 6. So I think my r value is 1/3. But let's see if we can prove that. We already know the a value, right? So let's see if we could just prove that real quick. Well, when x is 1, g of x is negative 2. So I could say negative 2 equals, my a value is negative 6. I'm just following this function, by the way, guys. I found my g of x value of negative 2 for when x is 1. A value is negative 6. Apparently I don't know the r yet, and then I can raise that to the power of x, which in this situation is 1. Okay, so I'm just trying to write down what I know for this function at this point in time on the graph. Well, let's just divide both sides by negative 6. Cancels out. I have just an r over here, and negative 2 divided by negative 6 reduces 1/3. So look at that. Sure enough, I was able to find my r value pretty easily. So I could write the function as negative 6 times 1/3 to the power of x. Now I can evaluate this. Now I can plug in a negative 1 for x. So let's go ahead and do that. I'm probably going to have to do that over here on the side. So remember that my function, I know it got a little messy there, but it's g of x equals negative 6 times 1/3 to the power of x. Therefore, g to the negative 1 equals negative 6 times 1/3 to the power of negative 1. Okay, remember that negative symbol just means that you flip whatever is being raised. So let's just get rid of the negative symbol and go ahead and flip this. It would be negative 6. The reciprocal of 1/3 is 3. And 3 to the power 1 is just 3. So really what I have here is 3 times negative 6. So g of negative 1 is negative 18. So I found the value that they're looking for. And let's just verify that that makes sense. It does look like it's going down and down and down, so negative 18 would be a reasonable number. Plus, if we're just going back 1, negative 6 is a third of negative 18. So yes, negative 18 makes sense. So I would write that as my answer. I'm checking to see if it makes sense, because if I got like a positive 27 for negative 1, that would not make sense because my graph is not approaching that, right? It doesn't seem to be approaching that as I get closer and closer to negative 1. Okay, so another problem for you guys to try. Remember, see if you could find the initial value just by looking at the graph, and maybe even see if you could just make an assumption of what the r value is just by looking at the graph as well. So go ahead and give that a shot and evaluate the m of 6. And then unpause the video when you're ready to check your work. Okay, I saw that the a value was 9, and just because that's where it intersects the y-axis, so therefore my a value is 9. And then I saw if I went over 1, it reduced by 1/3 because it went down to 3. So my r value therefore must be 1/3 because it went to 1/3 of its initial value. And then it keeps doing that too. I could also see it too, that it goes down to 1 and so on. So it's going to keep being reduced by 1/3. Therefore my r is 1/3. So I just went ahead and plugged that into my function. And then I evaluated for the number they gave me, which was 6. So I have 9 times 1/3 to the 6th power. Order of operations, again, remember, says that I have to do the exponent first, so I get 1 over 7/29. So that's like 9 over 7/29, which reduces down to 1 over 81. So m of 6 is 1 over 81. Alright, see you guys on the next video.